So do you see that this was asked in 2023 and again in 2024? This is last year slot 1. This is last year slot 2. All right. So let's move ahead. System consistency for two variables. This is a highly sought after topic, something which is periodically asked in your CAT exams. You can expect something actually just to come out of this. So we a moment ago we said that two variables, one equation of two variable actually means a line. So ax plus by plus c is equal to 0 is actually a line. Let's say this is your line number 1. If I want to draw another line such that it never intersects this red line, what should that other line be? That other line will have to be parallel to this red line. Because lack of intersection would mean that there is no point where for the same value of x you are getting same value of y, which means there is no solution for this. So no solution graphically means that the both the lines are parallel. All right, I have drawn this with black. What about a unique solution? What line should I draw so that I get a unique solution? Any line which intersects this. This is your unique solution. What if you want to have infinite solutions? Infinite solution means that the lines will actually have to be the same. So your line, the new line will going to be the exact same line. So graphically, this is what is meant by system consistency. For us, maybe a more relevant factor is algebraically what does that mean? For example, if I have a1x plus b1y plus c1 is equal to 0 and I have a2x plus b2y plus c2 is equal to 0. What does it mean to have no solution? To have no solution, you want the lines to be parallel. How are lines parallel? When the slopes are equal. But you don't want the line to be the exact same, because that would be the infinite solution situation. You want the intercept to be different. So you will make C1 by C2 different. This is the condition for no solution. This ensures being parallel and this ensures having different intercept, which was important. Otherwise, the lines would have been the same. So you have shifted your line somewhere. How about a unique solution? If the lines are not parallel, will they always intersect? Yes. So I only need to ensure this. I don't even care about the intercept. If the lines are not parallel, they will intersect. Then there is no question of the intercept. So a1 by a2 not equal to b1 by b2 will ensure that you have a unique solution. Infinite solutions. You want both the lines to be parallel. A1 by a2 is equal to b1 by b2, and you want them to have the same intercept. So is equal to c1 by c2. This is your infinite solution situation. Internalize this will get asked. If not in this CAT, then next CAT they periodically do ask this many times. So internalize this. Now there's something I want to touch on. Highly unlikely that it will ever be asked. What about system consistency for three variables? What if you had an equation like a1x plus b1y plus c1z plus d is equal to 0, and you had three such equations with a2 and a3, b2 b3 and c1 c3, right? When will this have a unique solution? So there is something called as determinant. Again, this is optional. This is safeguarding ourselves. What if they ask this? This is that sort of scenario. We're not going to complicate this. You make a box like this with the coefficients. So you write all of the three equations like this and you make a box like this. Then you calculate something which is called as the determinant. Determinant is calculated by taking a1 into b2 c3 minus b3 c2. So you write plus minus plus here. So you have A1 into B2 C3 minus B3 C2. Then because the second column has minus, you put a minus. Now you select B1. You ignore these two and then you do A2 C3 minus A3 C2. So B1 into A2 C3 minus A3 C2. And then finally you will write C1 into A2 B3 minus A3 B2. This is called as the determinant of a system of equations. If this value is not equal to 0, you have a unique solution. If this value is equal to 0, then you can have the other two situations. And then we will have to check. And that is going to be definitely out of the syllabus. So just if you can internalize this determinant expression, this will safeguard you against system consistency for three variable, something I highly doubt will be asked. So if you ignore this, that is also fine with me. However, this is an expression that we have seen before. The area of a triangle in coordinate geometry looked something very similar to this. So should not be a big issue in memorizing this. So let us move ahead. Let's see the questions. So CAT 2023 slot 3. X plus y is equal to 4 and a plus 5x plus b square. They are saying this has infinitely many solutions, which means that the coefficients of this are following what? All their ratios are equal. So 1 by a plus 5 is equal to 1 by b square minus 15 is equal to minus 4 by minus 8b, which is going to be 1 by 2b. Correct? Using this, can you find the value of b? You will get b square minus 2b minus 15 is equal to 0. So you will get b is equal to 2 plus minus under root 4 plus basically 2 plus minus 8 divided by 2. So you will get b as 5 and minus 3. Correct? So these are the values of b. Corresponding to these values of b, you can find the value of a. A is equal to what? 2b minus 5. So when b is equal to 5, a is going to be 5 itself. And when b is equal to minus 3, a is going to be what? Minus 3 into 2, that is minus 6 or minus 11. So this is a, this is b, this is b, this is a. So what is the maximum value that you are getting? Minus 3 into minus 11, that is 33. The presence of maximum tells you what? That there will be cases, and the cases are getting introduced because of the quadratic, because two solutions are present. Yes. Another iteration of this from the last year itself. So do you see that this was asked in 2023 and again in 2024? So this is very important. Px minus 4y is equal to 2 and 3x plus ky is equal to a. A necessary condition to have no solution. What does it mean to have no solution? That the slopes should be equal but should not be equal to the ratio of the intercepts, which means you want kp is equal to minus 12 but you don't want k is equal to minus 2a. This is something you don't want. So this option aligns with your option number 1. This option is written wrongly. This is put wrong. They should have put equality, only then this would have been part of your answer. So because they wanted only one option to be correct, so they went with option number 1. Are we clear? All right. The second trick. Again, this is also very, very common. Completing the square. And a lot of people get confused, because if I give you a question like this and you don't know how to deal with this, it is going to be extremely difficult to even figure this out. And this is inviting. You might feel like, feeling, you might feel the need to attempt this. The idea is simple. I have summarized this for you in one line. If you have presence of power, you know if you have presence of powers of 2 4 etc for two or more variables, so the first thing that we identify is, when we are trying to complete the square, if you are given two or more variables and if you have presence of even powers, 2 or 4, then probably completing the square is the method that we are going for. First, let us look at it like this. How many equations do I have? I have two equations. How many variables do I have? Four variables, x, y, z, and a. Four variables, two equations. They have to give me something very, very strong. They have to give me a very strong constraint for me to bridge this gap of four variables and only two equations. So let us, substitute this. Let us say 4x square plus 4y square plus 4z square. I observed there are squares here, so I am already interested in completing the square. So I will write now, this is a, right? So this plus 3 should be equal to 4x minus 4y minus 4z. If I take everything to one side, I will get 4x square plus 4y square plus 4z square plus 3. 4x I am writing here as minus 4x, minus 4y I am writing here as 4 plus 4y, and minus 4z I am writing here as plus 4z. This entire thing is equal to 0. Now this 3 I am equally dividing into all three. Is this a perfect square? Is this 2x minus 1 whole square? Is this a perfect square? Is this 2y plus 1 whole square? And is this a perfect square? Now I am getting sum of three perfect squares equal to 0. Sum of three squares can be 0 only when each of them individually is equal to 0. That is the powerful constraint that I am talking about. Only this could have bridged the gap between four variables and two equations. So now you get x is equal to minus 1, x is equal to plus 1 by 2, y is equal to minus 1 by 2, and z is equal to minus 1 by 2. You put this in this equation and find the value of a, which is what they have asked for. This is last year slot 1. This is last year slot 2. If x and y are real numbers such that 4x square plus 4y square this is equal to 0, then the value of 4x plus y. Let us make the observations. How many variables do I have? I have two variables, only one equation. I need a constraint. X and y being real numbers is not a constraint at all, because in our syllabus only real numbers are there. So all numbers that they will give you are going to be real numbers. So this is not a constraint at all. This is a constraint for, if you go for discriminant sort of argument, but in this scenario this is not a constraint at all. Do I see, in my helpless state, do I see even powers? I see even powers here and here, so it feels like worth a shot to try and complete the square. So let us do that. Let us try and complete the square. So I have 2x whole square plus 4y square minus 4xy. Now because I do not have a standalone term with x. I have a 6y but I don't have something in x format, which means 2x will have to couple with a y to give me 4xy. So I will write this as 2x square minus 4 into, or rather minus 2 into 2x into y, which means to complete the square I will need a y square. Now this y square I took on loan from 4y square, which means it is left with 3y square minus 6y plus 3. Is this a perfect square? This entire thing adding to 0. Is first one a perfect square? It is a perfect square of 2x minus y whole square plus, if I take 3 common here, I'll get y square minus 2y plus 1, which is also a perfect square, plus 3 times y minus 1 whole square is equal to 0. What does that tell you? Sum of two squares is equal to 0 means they are individually 0, which means y is equal to 1 and y is equal to 2x. So x is equal to 1 by 2. So you put x is equal to 1 by 2 here and y is equal to 1 here. You will get your answer as 7. Last year. All right. The year before that, 2023, I have x square All right, even before I start writing, tell me how many constraints do you have? Sorry, how many equations do you have? You have one equation, you have two variables, they are asking me for the exact value. There has to be some constraint which they have not written for me, outrightly, which means I have to make some observation, and the observation is I see even powers, which means I will try and complete the square. So I have x square plus 4yx plus 4y square plus x minus 2y minus 1 whole square is equal to 0. Is this a perfect square? This is the perfect square of x plus 2y whole square plus x minus 2y minus 1 whole square is equal to 0. Sum of two squares is equal to 0, which means they are individually 0. So x is equal to minus 2y and x minus 2y is equal to 1. Find the value of x, find the value of y. You don't actually need that. You are already getting x minus 2y is equal to 1, which is what they had asked you for. So the answer is 1. So you don't need the individual values. All right. 3 years ago, x square minus xy minus x is equal to 22. Y square minus xy plus y is equal to 34. If x is greater than y, then find x minus y. How many equations? Two equations, two variables. So technically, I don't need any constraint. And as you will see, there is no constraint here. Let us add these two. You can either add or subtract. Let us add. You will get x square plus y square minus 2xy plus y minus x is equal to 56. This is x minus y whole square minus x minus y is equal to 56. If I replace x minus y with z, which is what they are asking me for, I get a simple quadratic here. I can get the value of z. Z is going to be 8. You can also see the answer immediately. All right, moving on. So, this is the last thing I wanted to discuss, successive division. Not asked very frequently, but if it is asked, there is only one way to do this. You don't start with the information, you start from the ending. So a gentleman has decided to give few children uh, you know uh, toffees in the following manner. He gives half of his total and one extra to the first child. So let's say he had total, he give half plus 1 to the first child, which means he is left with what? T by 2 minus 1. Now to the second child he will give half of this plus 1. He will be left with t by 4 minus 1 by 2. Yeah, something else also will be remaining, t by 4, uh, actually plus 1 by 2. This is what will remain. Once more, if you do, you will get t by 8, then you will get t by 16. This is going to be unnecessarily complicated. So maybe let us see what we can do instead. Yeah. So basically, if I have t toffees at any given time, I will give t by 2 plus 1 to a kid and I will be left with t by 2 minus 1. All right. So let us start, from the initial situation. This is my situation initially. I gave something to the first kid, then I am left with something. This something I divided, I gave something from this to the second kid, and then I will be left with something. This I gave to the third kid, then I will be left with something. This I gave to the fourth kid, then I will be left with something. And this I gave to the fifth kid, and then I am left with zero amount. Now, for this node, if I look at this node, 0 corresponds to what? T by 2 minus 1, which means t by 2 minus 1 is equal to 0, or t is equal to 2, which means the value here was 2. So far, are you all with me? The value here is 2. Now the value, t by 2 minus 1 is the number of toffees which would have been left here, and it is equal to 0 because they have said ki he could only take care of 5 children. So there is nothing left for the 6 children, and anything that the 6 children would have gotten, it would have been from this particular node, right? So this particular node value is going to be 0. That is the trick that has to be identified. So after this, if this is 2, then this will become 4. There's a, at the same level there is a gap of 2, so this becomes 2 plus 4, 6. If this is 6, this is 8, so this becomes 6 plus 8, 14. If this is 14, this will become 16, 14 plus 2, and this becomes 30. And if this is 30, this becomes 32, or total becomes 62. This is literally the only approach to solve this question. If you start from this number and go down, it is going to be 0. Yeah, so the trick is that the last node, the one that does not exist, has a value of 0. Because if there was something left here, he could have given that to the sixth kid, no? Even if, let's say, one toffee was left, he would have tried to give half a toffee, which he couldn't have. Then he would have given one additional toffee. So he could have taken care of sixth kid like this. So there has to be 0 toffees left in this situation. All right.
Sir,
Yes, Chetali.
so can I ask what if the word problem had something left as, he's left with one toffee
Yeah. So then
after.
you would have written 1 here. And then your t by 2 minus 1 would have been equal to 1.
Okay,
Or
got
your t would have been equal to 4. So this node would have had 4 toffees. And then
it.
you would have reversed your calculations.
Yes.
Yeah.
Yeah.
All right. So, all right, folks, that is it for today's class.